Okay, hi everyone, welcome back. It is 12 o'clock toward the time up there, so we can begin. So today we'll be going over the command line. As a reminder, I will not be taking attendance today. We'll start taking attendance next week using UCF here, so be sure to bring your phone or prepare to write your name on a manual attendance sheet physically. Also, office hours will begin next week as well. The TA, Sanam, will have office hours on Monday. Wednesday and Friday, I'll have office hours on Tuesdays and Thursdays. I believe Sanam should be back right now. He is on a trip in Azerbaijan, where he's from. He should be back though by now. Okay, so today for this lecture, also as per popular request from students in previous semesters, I've installed a screen key tool on the bottom here so you can see what I'm typing. If that gets annoying, just raise your hand and tell me. If most students don't like it, I'll just turn it off. It'll be very useful, I think, when I go over some Vim commands, because that often confuses people, how to use the Vim editor. Okay, so let's begin by going over the homework. This is how I'll begin most lectures, by going over the previous homework. This one is a little different because, unlike all the other lectures, the homework is actually not due yet because it's the academic engagement activity. It's not due until Friday. It's a federal requirement that I have to make it due this Friday. So you'll actually be given the homework basically for free this time. So raise your hand if you have not done this homework yet. Okay, it's a pretty simple assignment, I think, if you just follow the directions. But it is easy to perhaps maybe overthink it. All you have to do is just connect to Eustace using SSH from the command line, and then send me a screenshot that you connected. Did anyone have any issues with this or any questions about how to complete this homework assignment? Yeah? Eustace 3. Okay, the reason why you can't use Eustace 3 is because for the grading server, you have to have certain authorization keys on your account, and those are only on Eustace 2 or whatever Eustace you log into normally. So you won't be able to upload your projects. It won't matter for these homework assignments. When you go to complete the projects and exercises, if you are on Eustace 3, you'll be unable to upload your submissions to the grading server. Yeah, it's a good question. Yeah?
This is just in general. If we try to use Eustace off-campus, where do we find the, what's it called?
VPN?
Yeah, VPN.
Yeah, so you'll want to go to, actually, can anyone say where on the course webpage there's the answer to this question? Maybe a hand? Okay, so on the recommended reading, right here in the schedule, there's a page for connecting to Eustace. And it has information about the VPN and everything. So read the friendly manual. No, I don't want to make you feel bad. But yeah, it's on the homepage. It's on the homepage. All right. So let's see, where were we? Homework 1. So if you are on Windows, you might have noticed that Windows actually has an SSH utility built into the command line. You can already use it there. So you don't need to install virtual machine or anything. You can just use SSH from the Windows command line onto Eustace. This exact command, I believe, should work. And then once you're on Eustace, you're on a Linux machine, and all the subsequent commands you'll be using for later projects, homework assignments, etc., should work just out of the box because you're on the Linux environment. This should also work on Mac OS, and if you're on a Linux machine already, then of course this command will work. So it should be a fairly easy homework to complete. And I'll be actually demonstrating this in a few minutes. Okay, so I'll close this window if there's no questions. Okay. And today we're going to be going over the command line. So we're not going to use the slides much today. I'm going to be reading the speaker notes and going through them, but it's going to be very interactive, this lecture today. I'm just going to be on the command line here, and I'm going to be introducing you all to all the different command line tools and utilities that we'll be using throughout this course, the basic tools. So for starters, we're in the bash shell. Or I'll just type in this command, bash-v, or version. So we're using this version of bash. That's what I'll be using for this course at least on my machine. GNU Bash, version 5.2.21. Bash is a shell. It is a language we use to interact with the kernel, with the level of the hardware and software stack that interacts directly with the hardware. So I don't know if any of you are familiar with Python, or maybe Ruby, or another scripting language, maybe JavaScript. Bash is another scripting language, but it is made specifically for interacting with the kernel, with the shell, or it is a shell. So some of the ways we do things, like calling functions, is going to be different from how you might be familiar with a language like Python. And you actually can change your shell's default language to be Python, but you'll see quickly that that'd be a bad idea because of the way things work with Python. It would be really annoying to try and do anything with a command line if your scripting language is anything other than something like Bash. And there are other shell languages out there. There's K-shell, Fish, yeah?
So we update our bash to match that exact version?
No, what you should do is, if you want to make sure you're in the exact correct version, use the version on Eustace. So run that command I just ran, bash -- version on Eustace, and you can see what version they use there. I'll show it in a few minutes. Or you can just log into Eustace and use theirs. That way there's no discrepancy at all, guaranteed. Okay, so let's get started. The first thing we should do is connect to Eustace. So I'm going to show you two ways to do this. One way is by typing out the long and painful command that we typed out for the homework. And you'll see I didn't have to enter my password. That's because I've configured my SSH client to have the password saved, so you don't have to enter it every time. In fact, I've actually configured this to the point to where I can actually just type in SSH Eustace, and press enter, and it just connects immediately. I don't have to enter my username or the whole long host name, eustace.ecs.ucf.edu. I don't have to enter any of that. I can just connect by typing in SSH Eustace. And if you want to see how to do that yourself, read the instructions on the command line page, the lecture notes for this lecture. We have instructions on how to set up these so-called keys that let you log in very quickly onto Eustace. I recommend doing it now. The earlier you do it, the more utility you get out of having done this, because you'll be logging in more often throughout the remainder of this course. And if you don't want to read one of these recommendations or our instructions here, you can click on the link to the Eustace page that I had just shown earlier. And there's a link here, setting up an SSH key, and this is an external page that maybe has clearer instructions if you're perhaps interested in seeing that. Yeah. So I recommend, if you can, set up your own SSH keys. It'll be different instructions if you're on Windows. I'm not sure how it would work there, but these are instructions for Linux machines. Okay, let me go back. Right. And again, the reason why you want to do this is because it'll let you just type in SSH Eustace and log in immediately to Eustace, which to me is a lot more convenient than having to type in the whole long username and hostname. All right, so we are on Eustace. What you'll see here is the command prompt. I'm going to clear the screen. The command prompt here begins with my username, and then the host name where I am. This is net1547. Then we have this little tilde. This tells us where we are in the machine. I'll explain more about paths later, but this basically tells us where on this machine we are. And then a $sign usually is what you see as the prefix of a command. So now that we're here, we can start entering commands on this machine. The first command we'll use is going to be ls. ls is short for list. So we list the contents of the current directory that we are in. So if you're coming from a Windows or a GUI File Explorer background, you might be familiar with folders. A directory is another name for a folder. So we are currently in the tilde directory. I'll explain more what that actually means in a second. And if we list the contents of this directory, we see there are some scripts here, some directories. These are all the grading scripts. I'm not going to be going through these because they have the answers to all the assignments. But these are all the directories that contain the grading scripts for this course and in previous semesters as well. Now, if you want to get more information about a command, there is another command that we can use to get more help for a command we've already that we're using. Does anyone know this command? Can anyone guess what I'm going to say? Anyone who uses Linux or Bash? What command do we use to get help for another command? Yeah? Man, yes. So there's actually two ways to get help. We're going to look at man first. So man ls, and this will give us a so-called man pages, short for manual pages, about the ls command. And we can see a breakdown of what the command's name is. Oops, I'm a little bit too high here. The command's name is, we can see it's ls, the potential arguments you can give to it, a description of what the command does, and some flags. So all these things that begin with a, or I'm sorry, with a dash, they are options. Options that have no parameters to them are just called flags usually, or switches. So most options or flags typically have a long name, so dash dash all or dash a. So we can test this out. If we do ls dash a, we can see there's actually quite a few more directories and files in this directory that we are currently at. They're just hidden. They're not displayed by default. And the reason why they're hidden is because their names start with a dot. So on Linux machines, you can make files hidden by just starting their names with a dot. So again, if I type in ls, we can see these directories and files appear. But if I type in an ls-a, you can see that more appear. All the ones that begin with a dot also appear. So you'll notice that I've been clearing my screen pretty frequently. The way to do that is to press Control-L. Or you can type Control-Alt-L. The difference is that Control-L, if you press Control-L, this might work. Let me see. Control-L. No, so on my terminal it doesn't work. But if you press Control-L normally, you're able to scroll up and see your history. With Control-Alt-L, the history is cleared entirely. So Control-L or Control-Alt-L. One of those two key combinations will work. And if you don't want to use that, if you want to use the actual underlying command, there is a clear command that clears the screen for you. But I've configured mine to remind me to just use Control-Alt-L so I go faster. But do as you will. You can use clear, Control-L, Control-Alt-L. They all just clear the screen. Okay. Last thing I want to show, basics of the command line here in this step. We can write comments as well. So I could say ls, run ls, and this would actually do the same thing as just ls. Everything after the hashtag is ignored. So I could say hashtag ls, and nothing happens because the ls command was commented out. Okay, any questions so far? All right. So we are on a remote machine, and we are on its file system. We are navigating its file system currently. So there are two kinds of so-called paths, ways to specify a file within a file system. The first way is through absolute paths. So absolute paths, for example, just slash, are ones which begin with the root directory. So file systems form a hierarchical structure, and the beginning of a file system is the directory path. Maybe what would help here is if I show this diagrammatically. I'll use the tree command, and you can see that there is a tree-like structure that forms with directories given, with the current working directory. You can actually specify a level here, -L1, L2, and that gives me a limit to how much I nest here. But you can see there's a tree-like structure that forms with paths on a machine. So within the COP3402 Fall 2026 directory, there are the subdirectories Cogen1, Cogen2, Cogen3, and slang format. That's the name of the language we're going to be writing this semester, slangs. It stands for simple language. So, let's see. So we are currently in a subdirectory on the machine. We can see what directory we are currently at by typing in the pwd command. It stands for print working directory. So we're currently at home net and then my NID. Tilde, the tilde here is a shorthand for your home directory. So my home directory is homenet br095187. This is an example of an absolute path because it begins with a slash. The absolute path always begins with a slash. It starts with the root of the file system. So that tree-like structure we saw before, the very root of that tree is going to be the initial slash, always, for a given file system. Now the other kind of path that we have available, or that we can use, are relative paths. They are relative to the current working directory. So if I type in something like ls ./cop3402 fall 2026, this is going to be relative to my current working directory. So the contents of that directory, so the dot refers to the current directory. Within that directory, find the subdirectory cop3402 fall 2026 and then list its contents. Now on the other hand, if I were to try and specify this as an absolute path, I would get an error because there is no directory underneath the root directory called cop3402 fall 2026. One more thing I want to point out here is that if I do ls-a, you'll notice there are two directories which seem to have no name, dot and dot dot. Does anyone know what these refer to? Yeah?
Isn't it just hiding other files when it's not printing?
Specifically, what are the dot and dot dot? So they are hidden, but what specifically do they refer to? They're special files, yeah?
Dot is your current directory, dot dot is the one directory.
Yes, so dot is always going to be the current directory, dot dot is the directory above it. So if I type in pwd again, we can see my current directory is actually homenet br095187. Haven't shown this command yet, but there's a way to change your current working directory with cd. So if I say cd dot dot, which directory should I be in after running this command if I'm going up one level in the hierarchy? Yeah, homenet, /home/net. So I'll type in cd, and you can see my path here in the command prefix has been changed to reflect my current working directory. And I can run pwd to be sure, and yes, I'm in the homenet directory. I'll go back to here. And now just to make sure this is very clear, I want to try and draw this out, an example of this structure here. So for instance, we have, let's say, a root directory. I'll make this a bit bigger at the top here. And if I were to ls the contents of this root directory, you can see there are some subdirectories here. The bin directory is one of them. The user directory is another. Serve, sys, etc. So the user directory is underneath the root directory, so I could say user is here. Actually, what I'll do is copy this subdirectory. And we can draw a line just to signify that these are connected. And then if I were to list the contents of the user directory, you can see there's another directory in here called bin. So we have another subdirectory underneath that we can list. As well. And then of course underneath each of these directories there are these special directories dot and dot dot. So for instance here we would have dot and then dot dot. And then same thing for user bin. And I can just draw some arrows here to connect these directories all to each other logically. And of course, the dot directory refers to the user directory itself, the current working directory. The dot underneath root refers to the root directory. What directory does the, well, if I were to say, for instance, what directory would I be placed in here if I were to type in this command, cd/user/dot dot? If dot dot, what does dot dot refer to again? Oh, yeah.
The root directory.
Yes, yes. Because again, dot dot refers to the parent. So here, dot dot would refer to the root directory. So I guess maybe a potential trick question, or yeah, trick question maybe. What does this refer to? If I say the parent of the root directory, where does that go? Any guesses? Does anyone know? Okay, so the root directory is special, and that the parent of the root directory is the root directory itself. It's the only directory for which that is the case. Yes, it's the root. It's the root of the tree. So for this case, we'll say dot dot refers back to the root of the tree. So when we have directories containing other directories, we get this hierarchical file system, or it's a tree-like structure. So this is where some of the knowledge of CS1, which is a prereq for this course, should come into play. You should recall trees from CS1. This is a pretty simple tree-like structure here. And for one of the assignments later in this course, you will be navigating this tree-like structure using paths. So be prepared for applying some of that knowledge from CS1, that knowledge of trees for this course. Okay, let me go back to my home directory. I can do that with the tilde shorthand again. So I'm back here. Let's see. So we've been using the cd command a little bit so far. We can cd into the home directory or the root directory, cd into subdirectories underneath that. /user/include. Go to different directories, list their contents, cd back to our home directory. But does anyone recall, if we wanted to learn more about the cd command, does anyone recall what command we should use for cd? What do you think we should use if we want to get more information about a command? Man, right? So I'm going to introduce a new concept to you. That doesn't always work. For some commands it doesn't work. And the reason why is because cd is actually not a separate command that we're invoking. So if I were to, for instance, ls the contents of user bin, I can see that user bin ls is an actual file itself. This is the file we are running when we type in ls. When I say ls, what's actually being run is user bin ls. And I can prove this to you by invoking it directly here like so. And we have the same output. It's just not colorized, but it's the same output. So some commands, though, are not in that user bin directory. No such file or directory. So how are we able to call them? Well, remember, we are in a scripting language. We are using bash. And as you might be familiar with in Python and other languages, there are certain functions that are built into that language. cd is one of those functions that are just built into bash. And to find that out, we can use a command called type. Specifically with the -a switch, so we can see all the types of a command. Type cd, we can see cd is a shell built in. Now if we were to do this with ls, we can see ls has an alias, which enables the color flag by default. And it also has some locations on your machine. So it's actually a separate program that we're invoking, not a shell built-in. And to get information about shell built-ins, we don't use man, we use help. Oops, sorry, not help. Help. Help cd, yeah. And this will print out some information about that built-in. So I'm just telling you all this because very often in tutorials about bash, people will tell you just use man. It'll give you all the information about every command you want to use, but very quickly you'll try and use man on some command that you use often like cd and get no output and be confused as to why you're not getting any results. I just want to make very clear, some commands are not actual separate programs that you're invoking and do not have man pages. You have to use help for them. And you can tell the difference by using type. So again, type -a, ls, you can see the types for ls. Type -a, cd, you can see the types for cd. If we omit the -a flag, we just get the first result, which is the one that the shell will use by default. So I prefer to use -a usually to get all the results for each command, so we know what we're dealing with. Yeah, question?
If ls is like a built-in program, is there any way to actually examine what's in that program file if it's an executable file?
It's not an executable, it's a built-in function. So you'd have to look at the bash source code itself. Yeah, so bash is written in C, it's open source. You can look at the code yourself and you can see what CD is doing. But generally what CD is doing, the reason why CD is a shell built-in and not a separate program, is because we are changing, with CD, the current working directory, which is an internal variable inside of bash. So it has to be a shell built-in because we're changing a variable inside of bash. An external program cannot do that. Okay, so that's the basics. Now I want to go over how we can really accelerate our command line usage here. So does anyone recall some of the virtues of a great programmer that we talked about in the previous lecture? What were some of the 3 virtues that we had talked about? I heard someone say it, yeah?
Laziness.
Yeah, laziness, hubris, and anyone have the third one? Impatience, exactly. And so we're going to be looking at laziness and impatience and apply them directly now to the command line to go faster. So the first thing is, really the feature we're going to be using now is tab completion. So I don't know how many people are familiar with tab completion, but what this lets us do is type in the name of a command. So I can say, for instance, or type in the name of a directory. I could say ls/u, press tab, and it auto-completes to user. Please, please, please practice using this. I cannot tell you how frustrating it is to see students come to office hours at the end of the semester and still type out full path names manually. Because we're going to be dealing with long names throughout the semester, and you might think, oh, well, it doesn't make much of a difference. It's like 2 letters here, user versus U and then tab. That's like not much of a difference in terms of keystrokes. But it accumulates, especially when you have longer names that are not just 1 letter long or 3 letters long. You impose a tax on yourself over time. So please practice using tab completion. Another reason to use tab completion is not just because it's fast, because it lets you go faster typing out names, but also because it lets you quickly get information without actually typing out a full command. So for instance, in my current directory, if I type in cd cop, notice that I only typed in cop, but when I press tab completion will complete the longest common prefix among the possible results in my current directory and print those results for me. I didn't even have to type in ls, I only got the output for the names that I wanted that matched. This is also useful because if I wanted to say cd into a directory called foo and press tab and I get no results, I don't even have to enter this command to know that it's not going to work. I get no tab completion. So remember we talked last time about how programs seem to anticipate what you need? This is an example of that. Bash, the developers of this feature, predicted that you might want to quickly be able to tell what directories are present in your file system, quickly type out their names, quickly check if they exist, and what their names are. And so this is a way to quickly do all of that. So really I recommend strongly just practice using tab completion, or at least get in the practice of almost spamming tab when you're on the command line. Okay, let's see. Okay, any questions so far before we continue? With any of the commands we've seen, we've only seen a few. All right, so now I want to show some more shortcuts we can use to quickly edit on the command line. Let's say we start to type out a long command here. We'll say user include. And I realize, let's say maybe I typed in KS by accident. And I want to fix that. There are 2 ways to go to the front of the line in Bash. The first is to press the home button. Now the home button is kind of far away usually. It's inconvenient to reach for on your keyboard. You can also just press Control A. A for beginning of the alphabet, the first letter in the alphabet. Control A, hop right to the front of the alphabet. Many of these key bindings that I'll be talking about now come from Emacs. You can also configure your shell to use Vim key bindings, but Emacs key bindings are arguably better for the shell than Vim key bindings. We'll see why when I go over Vim shortly. So Control A, beginning of the alphabet, beginning of the line. To go back, so I can fix this issue, change that to ls, and now I want to go back to the end. I can press Control E for end. So again, I recommend learning these two key bindings, A and E. They're pretty useful. There's one that I'll show later that is more useful, I would say. I don't have this in the notes. I need to update the notes with it, but I'll show it soon. Okay, so backspace, deletes the character behind you. One you might not be familiar with is alt backspace. That deletes a whole word behind you. So I had include here. I press alt backspace. It deletes the whole word. That's really useful for changing parts of a path without deleting the whole path outright. If you want to delete the whole path, Control W. That deletes a whole path behind you. So again, GNU. I could say Control or Alt backspace, delete one part of a path. Control W, delete the whole path preceding my cursor. So I recommend practicing using these different ways of deleting text from the command line. It'll help you out. Okay, a few more. We can use Alt B to go back a word and Alt F to go forward a word. So B for back, F for forward. I recommend practicing using both the left and right Alt keys when you're typing. So the proper way to type is to, if you're going to be using a modifier like Alt, you should be holding the modifier with the opposite hand from which you press the key. So if I'm pressing F, F is typically on the left-hand side for a QWERTY keyboard. You would hold Alt with your right hand and press F with your left hand. Same thing for B. B should be pressed with the left hand, so same thing. I'm only telling you this because if you type a lot, which you will be typing a lot as a programmer, it helps avoid getting RSI and repetitive strain injury if you learn the proper way to type and are typing deliberately with the correct form. So, and using shortcuts as much as you can. Okay. So for deleting, we can press Control D. That deletes the character in front of the cursor. We can go back a single character by pressing Control B. So instead of Alt B goes backward, Control B goes back a character. And then Control F goes forward a character. So ways to quickly get around without using the arrow keys. The reason you want to avoid using the arrow keys as you become a better programmer is because you have to reach. Move your hand off the home row. Really great programs, especially a lot of these system software editors will be using, these terminal-based editors. They're designed with the mindset of you never having to leave the home row when you're typing. Your fingers can always stay on ASDF, G, H, J, K, L. Vim and Emacs both have this sort of mindset, because moving your fingers to the arrow keys is just annoying and it kind of disrupts your flow when you're typing. It sounds like minutia, but trust me, the more you program, the more code you write, you will understand. I'm pretty confident you will understand. Okay, one more. We used Control D to delete a character in front, so I'll go back here. And then Alt D to delete a word in front. So Control is like a character, Alt is like alternative. That's how you can remember those mnemonics. Okay, last ones. One that I use a lot, this one's very useful, is Control U. It deletes everything before the cursor on the current line. Where that is extremely useful is when you're trying to log in, and you may have noticed how on Linux systems, when you try to log in and type your password, the password is not echoed back to you. If you make a typo, you can't know whether or not you deleted the whole password, so you can just press Control U to delete everything you typed so far. You can't see it, but you deleted it all, and you can just start over without having to work out whether or not there's any typos still lingering in your password that you're building, that you're trying to type. Yeah? I'm going to guess undo. I'm not sure. Some of these are pretty archaic. there's not a great explanation for some of these acronyms we're going to see. Right? It's going to be a recurring theme throughout this course. Really weird choices of acronyms and names for things. Yeah. Okay, another one that does have somewhat of an acronym is I'll say ls/user include, and let's go back to the beginning again. So Control U deleted everything before the cursor, Control K deletes everything after the cursor. That's going to be K for kill, maybe you can think of. A very violent way of putting it, but yeah. We're going to see the kill command again later, and it's not going to, well, there's a command called kill, but it actually doesn't do what you think it does. We'll see that later as well, another bit of weird trivia you just have to know. One more. Control Y, that yanks. Oops. Yeah, then I guess pastes. Yeah, I don't use this one a lot, so I'm not exactly sure what the semantics are, but basically you copy and paste with Control Y. Okay, there is a way to access the history of all the commands you've ran. So if I type in the history command, which, let's check if it's a built-in or a separate command. What do we think it is? Do we think it's a separate program or a shell built-in? Checking the history of the previous commands we've run. And you're right, it's a shell built-in. Because we've ran these commands within the shell, so of course it makes sense for seeing the history of the commands we've run to be a shell built-in. So let's see what this looks like, the output. We can see all the commands we've ran, and I've configured my shell to also record the exact time at which I ran them, time and date. So I can know I have like a really good log of what I've done. Remember before in the previous lecture, we saw how Isaac Newton would take copious notes on creating his own grinding lenses? Same mindset here. Take copious notes on every command you ran, especially when you ran them. This is very useful when in research. You might want to have a record of what commands you ran to get some results. And honestly, and I think all software engineering endeavors, it's probably good to have this sort of log. So another way so there's ways to navigate this history very quickly. You can use the up arrow, but again, like I said before, the up arrow is something you kind of want, using the arrows is something you may want to avoid. So to avoid it, you can use Control P. P for previous, Control P for previous. You can go up to the previous command. If you want to go down, you can use the down arrow, but again, you want to avoid the arrow keys, so we can use Control N for next. So I recommend strongly getting in the habit of pressing Control P or up arrow to go back to the previous command and then modifying that to run a new command, or just running the previous command again. Believe me, it will save you a ton of time if you can remember just to use the saved history to your advantage instead of retyping commands every single time. You'll save a lot of time in the long run if you do that. And one very powerful utility with the history is Control R. This is reverse search through your history. So if I remembered vaguely in the past, I typed in some command that involved user include, I can just say user include, and there we go. That's the command that I typed that used user include. I don't remember exactly when I typed it, but I can find that previous command from my history. This is really useful again in like research or software engineering efforts when you've typed some long esoteric command that you had to do a bunch of Stack Overflow Googling to obtain, and then you ran it and forgot to save it. You can press Control R, type in the general like a fuzzy search of what the command was, just a substring of what you're trying to find, and you'll find it in your history. And to cancel this, you can just press Control G. That comes from Emacs. I don't know why it's G, but Control G is universal cancel in Emacs. So one way you can actually save commands that you're typing, let's say I typed in ls user include again. I can press Control A, Control A, hashtag space, enter. And now this is saved to my history, but I didn't actually have to run the command. So a way to like quickly and kind of maybe hackily, I don't know if that's really a verb or an adverb, but save your commands for later. I believe there's another way to do this that's even faster. It's Control, let me see what the key binding was here. There we go. So that was Alt-Shift-3. Can anyone tell me, if you hold Shift and press 3, what letter that is or symbol that is on your keyboard? Hashtag, right? So if I hold Shift and press 3, I get hashtag. So Alt-Shift-3 will immediately jump to the start of the line, enter a hashtag, and then enter that command. So if you want to do that flow of saving previous commands as comments, you can quickly do it by just typing Alt-Shift-3. So these are all just little tricks that I think is worth spending a lecture on, because you're going to be using you'll be able to use these for the entire semester afterwards. So if you start using them now, you'll be able to reap the benefits for longer because you have the whole semester ahead of you. And believe me, the inverse is also true. If you don't start practicing these, you might develop bad habits and kind of cripple yourself as a programmer in the future. So, yeah?
Does the lead code exist specifically for like the command line?
Like lead code?
Yeah, so something similar to that where it's just prompt
There's a website, I think it's called like War Games or something. War Games, yeah, overthewire.org, War Games. Basically, on this website, you log on to a remote machine and you practice, I think it's like hacking into the machine and doing things like that, and you get practice using shell commands. So this is somewhat similar, but it's not as shrink-wrapped as leak code, where you have all the test cases and whatnot given to you, and it's just dopamine hits and feedback loops and whatnot. It's not quite that. Okay, any other questions? All right. So let's look at some more commands here. Let me see if there's any files here that I can open up. Well, just cat at the contents of this one, vcgrader.sh. So this does not have any of the actual answers to the VC exercise in it. It's just the grading script we use. I can use the cat command to print out the contents of a file. Can anyone guess what cat stands for? Concatenate? Yes, that's exactly it. So I can say cat vcgrader.sh, and that'll actually print out the contents of this file, this shell script. If I create two files, let's say I create a file called hello.txt, and then another one called by.txt, I can enter both of them, pass both of them as arguments to cat, hello by, using tab completion, and then their contents are concatenated together on the command line. That's why it's called cat. To read a file but page through it, you can use the more command. So I can say more hello.txt. Well, this is going to work. This is a very small program. More, or a small file, vcgrader.sh. I can now navigate through this using the arrow keys until I reach the bottom. One problem is that with more, I can't go, well, I can go up, yeah, but there's fewer features. I don't think you can search with more. No, actually, maybe you can. Anyway, the command that we usually use instead of more is less. So the joke is like less is more. So you would use less, and this is a bit better than more. If you reach the bottom, you aren't immediately kicked out of the file. So with more, you'd be kicked out of the file and sent back to the command line as soon as you reach the bottom. With less, you're not. You can go up and down, and yeah. And Emacs shortcuts work as well. And in a lot of these programs we're going to be using, Emacs and Vim shortcuts often just work. So I can use Vim shortcuts in less. You can't use Vim shortcuts in with more. You can use or J and K to navigate up and down in the file with less. So I recommend using less to navigate long files. In fact, when you run man, so if we run man ls, I believe the command less is actually being used under the hood as the pager for man pages. So if you learn how to use less, you can also navigate man pages more easily. And we're going to be navigating man pages a lot this semester. One of the things I want to show you how to do is get help and learn how to use a command or a C function without having to Google anything or use an internet connection. Being able to do all your learning and debugging offline using just man pages. It's really not as bad as you think. It's actually faster than using the internet if you learn the way to do it. Okay. One thing I'll point out that's very helpful, so if I type in man ls again, if you type in slash when you have less open, you enter search mode. So I can type in search for verbose, and I find all matches for verbose in this file. And say dash dash, and I get all matches for dash dash. When you find matches, the little letter n will go to the next match. Capital N goes back to the previous match. So I recommend learning how to use slash and then just practice using n, capital N, to go back and forth between different matches. So you might be used to like Control F in VS Code or any other editor you're using. Just press slash, and that's all you have to do to enter search mode. When you reach the bottom, it wraps back around. Okay, so now raise your hand if you completed the Vim or Emacs reading from the previous lecture. Yeah, I figured. Nobody ever, okay, one person did, that's good. Most people don't do them. I recommend again to do that reading or at least practice using Vim or Emacs because I'm going to be using it a lot throughout the semester and it'll help you to be able to follow along with what I'm doing. So for instance, I'm going to use Vim now. I'm not going to use Emacs this lecture. I'm going to use Vim for the rest of the semester. I'm going to show some basics of how to edit files with Vim. So let's create a file here. We'll just call it hello.c. So I'm in Vim. When you are in Vim, Vim is a modal editor. That means there are modes. This is different from VS Code or Nano or Sublime Text, where you're always inserting and modifying text. By default in Vim, if I type a letter like F, nothing happens. It's not being entered into the window, the editing window, the buffer as it's called. What I have to do is press, right now I'm in normal mode, I can press I to enter insert mode. And now I can type in commands and they're going to be, or text, and it will be entered into the buffer. The same keyboard shortcuts as before apply. So Control W deletes everything before the cursor. Not all of them, but a lot of the same keyboard shortcuts will apply once you're in insert mode. So I can type in now a hello world program. Okay, and now that I've typed in this program, I can save it by pressing escape. So I'm in insert mode. I can press escape to exit insert mode. You can see in the bottom left corner that status goes away. So I go from insert mode to just normal mode again. Now I can press Control W to save. So when I press Control, I enter command mode, enter the command W, press enter, it writes my file, saves it. And now that I've saved it, and you might want to take especially take notes of this because a lot of people don't know how to quit Vim. It's like a meme. So when you're in normal mode, so you just enter in Vim, you press escape, :Q. That will quit Vim. Yeah.
How did you say that again? I'm sorry.
So when you enter Vim, right now I'm in normal mode. You can see that because there's no status icon in the bottom left corner.
Yeah.
Hold Shift, press semicolon, so you type in a colon. You're now in command mode. You can press :Q to quit. Now what you can also do is combine saving and quitting by typing in WQ for write quit. And if you would like to quit without saving your pending changes, the changes you made in your between now and your previous write, Q exclamation point. That means just quit without saving. That also works. And what you'll notice is that when I open Vim again, I'm back, my cursor is back where I had left it. So I don't have to move around. If I have a big file, I don't have to go back to my current spot. Vim will take me back to where I had last edited it. That might be an option you have to turn on for your Vim. I'm not exactly sure. But it is a setting you can configure. And it's very easy to configure that setting. So I show you this because there's one more thing I want to show you now. So what we could do is type Control-Z, Control-Q, or I'm sorry, :Q to quit. And then we could run GCC to compile our hello.c file to a binary that we'll call hello, and then run it. Okay, let's say I want to change this. I can press Control-P a few times, go back into here, change this to capital W, write quit, do that whole process again. That works. We're going to learn better development workflows as the semester goes on, but one quick one you can do is to press Control-Z from within your editor. So when any process is running, Control-Z puts it in the background. We're going to learn more about this in a later lecture. But for now, how you can apply this knowledge is just Control-Z, background, run your commands, and then the FG command will bring the previously sent to the background program, running program, a process, back to the foreground. So now we're back in Vim where we left off. No need to quit it or anything. We're just immediately back. This is very useful if you're using Emacs because Emacs is slower to start up. So you might want to practice using Control-Z to send it to the background and then FG to bring it back to the foreground. So you don't have to wait for Emacs to initialize every time you run it. Yeah?
Why on like some screens does it like show like no such file directory?
What do you mean?
Because on when I was trying it, like I did like I went on Vim and did the hello world, and then when I saved it and exited, and then I tried doing GCC, it said no such file directory.
Make sure you're in the same directory as where you made that file. So you can check with ls to see if that file actually exists.
Okay.
So again, ls, you can see this hello.c file is in my current working directory. Hello.txt is in my current working directory. All these different files are here. Some things I will show quickly that I don't typically talk about, but we have time, so I'll go over them, is that there are lots of cool shortcuts within Vim. And Vim has what is called motions, so a lot of the commands you can type in Vim can be composed together. For instance, C begins the change motion. So if I say, so C is the change action, W would be word, so I can say CW to change the word past where my cursor is. So if I wanted to change this to fprintf instead, I can do that. Also moving around, also I can press X to delete the character under the current word, or the current character under the cursor. For moving around, I don't want to use the arrow keys. In Vim, I can stay in the home row by using H, J, K, and L. So J goes down, K goes up, H goes left, L goes right. I recommend learning those a lot. There are lots of games online, like you can play Snake using Vim keyboard shortcuts instead of using arrow keys. That'll help you learn the keyboard shortcuts pretty quick. And it also just takes practice, yeah?
What's the benefit to using Vim over traditional IDE?
The benefit is that Vim is one benefit, there are multiple. One benefit is that Vim is pre-installed on Linux machines already. Many Linux machines already have Vim pre-installed. So if you know how to use Vim, you don't have to set up your VS Code, Emacs, Sublime, whatever, on another machine. You can just SSH into it and immediately get running, get started. Because a lot of machines you may not have access to even install those pieces of software on. And if you want to use VS Code has, sure, like an extension where you can SSH into a remote machine and use VS Code anyway, but that installs a lot of bloat. And I will tell you, this semester, if you try to use VS Code to remotely log into Eustace, you will quickly reach the disk quota that we give you for your account on Eustace. So many students, they have this issue where they can't add any more files to their directory on Eustace because they used VS Code to log in. And now they've created all these temporary files or auxiliary files which prevent them from even saving anything else because they've reached their limit for storage on Eustace. So it's good. That's another reason. Another reason is that VS Code, as you might know, and other editors, have a button to open up a terminal window inside of the editor. So I can actually demonstrate this. I have VS Code installed. If I press Control-tilde in VS Code, a terminal window opens up. The terminal is inside VS Code. You don't have to interact with other programs. You don't have to learn as much. You're not really encouraged as much to learn how to use all the different shell commands we're going to be talking about in the semester. The terminal is within VS Code. Contrast this to Vim, where Vim, oops, I have some changes in that I haven't saved. Vim is inside the terminal. It's sort of inside out, other way around. And we were actually encouraged now to learn how all the other tools in the terminal work because Vim is sort of integrated in a sea of other applications. So this is sort of the monolithic versus modular architecture design of software. Emacs, VS Code, Sublime are more monolithic pieces of software. They try to include everything. VS Code does it with all its extensions that it has. Vim, you can install extensions as well, but you are encouraged to figure out how to use other tools, link them together with Vim to solve a problem. So for instance, one cool thing you can do in Vim, which you can't do in VS Code, is I can type in math here, and I can press exclamation point twice, and I can actually pipe the current line of text that I have to an external program. In this case, BC, that's basic calculator, and that actually computes the equation for me. I can pipe or send any text that I have in my editor directly to another program from within Vim. So these are all just little things you can find applications for. It's a lot more modular. And being able to use Vim motions to move around, you don't have to use the mouse at all, just helps you go a lot faster in the long run once you learn how to use it. You don't have to use the mouse to click everything like the VS Code. Another cool shortcut that I use a lot is CI change inside double quotes. Lets you change text immediately from within double quotes. In normal mode, press U to undo. CI open parentheses, change within open parentheses. Maybe you get the point. DAP, delete around a paragraph. CIP, or no, CI open braces, delete, change within open braces. Maybe you can see how these things are useful for editing code, because these are common structures you'll see within code. Curly braces, brackets, parentheses, double quotes. You can quickly change content within and around those things using Vim keyboard shortcuts. And this is all just to encourage you to spend some time learning how to use them. And if at the end of the course you don't want to use Vim, maybe you'll still want to use Vim keyboard shortcuts. There is an extension for VS Code that lets you use Vim keyboard shortcuts from within VS Code. So hopefully you'll see that I'm not crazy, that there is a reason why I use this editor. One more cool thing is that you can actually run shell commands from directly within Vim. So I could say gcc hello.c-o hello, and that will actually run the command from within Vim. And now I can run that binary from within Vim as well. I don't have to even leave my editor. I can just run all the commands here. And you can combine these commands to where you can run them all very quickly. I'm not going to show you that. You can even map them to other key bindings. So I can have a key binding mapped to compiling and running my code, so I never have to leave my editor. I just press a few buttons and I run all my test cases. I save and run all my test cases immediately. That's a lot faster than using the mouse to click something or running multiple programs from the shell. I'll show more of this later on in the semester, but there are ways you can go very fast if you know your tools well, which is again is something we reviewed in the last lecture. Knowing your tools well is one of the goals of this course. Okay. Any questions so far? All right, so I want to show a few more commands, and then we'll wrap up. The next one I want to show, I'll make a directory here, is make dir. This creates a directory. So I'll create one called temp, and I'll cd into it. Temp for temporary. Now, what I want to show is how to download files from the internet using the command line, because many of the projects in this course and homework assignments will ask you to do that. The command we use to do that is wget. I think W stands for web, I'm not exactly sure. So webget, and you can actually type in the link to a file. So I'm actually going to just copy this here. Going to go to the web page real quick and go to the command line, find this command here. Just going to copy what this string is here. Okay, so if I type this command in, it should download from the internet this specific file. And we can see a little loading bar that completed very quickly because it's a very small file, only 10 kilobytes in size. And now if I run ls, you can see we have this homework2.tar file here. So this is called a tarball. A tarball is just an archive file, like a zip file. Anything like that. This is just an example of an archive file. We can use a command called tar to unzip or extract this tar file. And tar is funny. You need to use a lot of flags. We'll use the X flag to extract, the V flag to be verbose and print everything that we extract as we extract it, and the F flag to extract a specific file. And we'll extract homework2.tar. And we can see here it extracts everything to this homework2 directory. One more thing I'll note is that tar is unique in that you don't have to pass the initial dash to the first set of flags. Most programs need to pass that. You need to use a dash for flags. For tar, you don't have to. Now we can cd into that homework 2 directory and list its contents, and this is everything that will be in the homework 2 directory given to you. You need to do this command, this wget command that I showed previously. You'll need to use this and this tar command to complete homework 2. So just a heads up on what you'll need to do for the next homework assignment. Okay. So now that we're here, I want to show a few more commands that deal with working with files. So if we want to create a file, the command for that is called touch. It's just to create a file or update its last modified access time. So we can say, let's create a file called readme.md. And now if I type in ls, we can see that file exists. It will have no contents, but it is created. If we want to remove a file, we use rm. So rm, readme.md. That will remove a file from the file that we give it, the path to be specified to rm. If we want to rename a file, so we have our makefile here. Let's say we want to rename it to makefile with a lowercase m. We can use the mv command. So mv makefile to makefile. So mv is used for renaming. It's also used, as the name suggests, for moving a file. So if we want to move this makefile into the parent directory, we can specify the path to the file we want to move, the source, and then the destination path. Now, if the destination path is a directory, then the file will be moved into that directory. So I'm specifying the parent directory. If we run this command, we can see the makefile is no longer here. But if I go back up to the parent directory and type in ls, we can see the makefile is now in the parent directory. We can put it back by using move makefile into homework 2. And there it is. So we can copy files as well. So cp makefile, makefile. And now we have 2 versions of this file, one with lowercase m, one with capital M. I already showed how to make a directory, but we can make directories using makedir, temp. We can remove directories with the rmdir command, but this will only work if the directory we're trying to remove is empty. So if I go up to the parent directory and try to run rmdir on homework 2, I get a warning, or an error actually, failed to remove homework 2, directory not empty. So the way we can remove directories is by using the rm command with the -r flag. Can anyone guess what the R stands for? Recursive, exactly. If I run this, it's deleted. Often, not always, but often, we'll want to pair the -r flag with the F flag. This will mean, we'll see this in makefiles in a coming lecture. This means to force deletion of a file. So even if a file doesn't exist, don't give me a warning message. So here, if I were to leave this F out, I get a warning. F means delete it. Don't emit a warning if the file doesn't exist. This works also if a file is saved as write-only. You can force recursive to delete that file even if it's listed as read-only. Read-only. The mnemonic I use is FR for real. Delete the file. Okay, and I think that's it. Yeah, that's it for all the basic commands I wanted to show. So if you have any questions, please ask me now or office hours starting next week. Yeah, maybe come to the front afterwards, yeah. Otherwise, I'll see you all on Tuesday. Please work on completing the homework on time.